So let us now look at few system functions and find out whether they represent minimum, maximum or mixed phase systems. So I've considered few system functions. All these are FR systems. We have to categorize them into minimum, maximum and mixed phase systems. So as we just now discussed the various definitions, all we have to do is find out the zeros. Now to find zeros, we'll have to express, we have to equate the polynomial to 0 and find out the roots. So the first system is 6 plus z inverse minus z raised to minus 2. And if I find out the corresponding roots, which can be done by equating this to So if I equate this to 0 and if I solve this, this can further be written as 6z square plus z minus 1 equal to 0. So all you have to do is solve it in your calculator. The zeros will be, there will be 2 zeros because of the second degree of this particular polynomial, and the zeros will be minus half comma 1 by 3. You can see both the zeros are inside the unit circle, and hence the first system becomes minimum phase system. So the conclusion is that H1Z is minimum phase. Okay, similarly for the second, third and fourth system, we will now keep on finding the zeros. If you do the same thing, if you equate the second system also, second polynomial also to 0, the zeros Z1 and Z2 will be minus 2 comma 3, and because the zeros are outside the unit circle, we conclude that the second system H2Z is nothing but maximum phase. Similarly for the third system, zeros, two zeros Z1 comma 2 will be equal to minus half comma 3, and for the fourth system, two zeros will be nothing but minus 2 comma 1 by 3. You can see 1 0 is inside the unit circle, 1 is outside the unit circle in both the cases, and hence third and fourth systems are mixed phase systems. So that's a simple way to classify given system or FR filter into minimum phase, maximum phase and mixed phase. Now I can extend these definitions to IR filters also. For IR filters, we will have system function h of z in the form let's say b of z upon a of z, where b of z is a numerator polynomial and a of z is denominator polynomial. From numerator polynomial we get zeros of the system, from denominator polynomial we get poles of the system. So IIR system is called minimum phase if all its poles and zeros are inside the unit circle. Now please remember that poles must be inside the unit circle, only then the system is stable. And when we categorize system into minimum, maximum and mixed phase, the first assumption has to be that system is stable. So for minimum phase, again the condition is same, that zeros must be inside the unit circle. We are adding that poles should also be inside the unit circle because we also want stability apart from minimum phase characteristic. So what is the overall definition of minimum phase for our filter? That both zeros and poles must be inside the unit circle. For system to be maximum phase, all the zeros will be outside the unit circle. Poles will again should be inside the unit circle. So the definition of minimum and maximum phase is same. For mixed phase IR filter, some zeros will be inside the unit circle and some zeros will be outside the unit circle. So the categorization for IR systems is exactly same. All you have to do is look at the zero positions again, and the definitions are same. You have to just verify one small thing, that poles are also lying inside the unit circle. Otherwise system will only become unstable, and then the categorization in terms of minimum, maximum and mixed phase does not make any sense.